Hi everyone, welcome to a new episode of Streaming Caffeine, and we try something different today. And we have three persons in this podcast: me and Gang coming from Timeplus, and Z from Claypot. Z, do you want to do a soft intro?
Yeah, sure. Thanks for having me today. Glad to have coffee together. So my name is Z. I'm currently co-founding a company called Claypot. We really kind of focusing on real-time machine learning. So essentially kind of helping companies to make real-time decisions. So imagine fraud detections, right? So where decisions needs to be made in, split of a second, right? Dynamic pricing, those are similar situations we're trying to help with as well. But kind of coming down to a technical point of view, right? So what we really trying to help is, if we kind of breaking down the real time decision into like smaller pieces, there's two main factors, right? So one is actually having a good model to be able to make decisions in real time, right? And the second one, which is closer to my heart, is about kind of getting real-time features ready to feed into the models, right? So now given, the large language model, landscape and evolutions, all that kind of stuff going on right now, we're also trying to figure out how do we kind of build an ecosystem to fit into situations like that as well. Yeah.
Yeah, cool. And I guess Z, you didn't mention that is you actually work on data streaming for a long time, right? And I personally read a lot of nice blog and YouTube. Yeah, for example, your blog is always very long and with a lot of technical details, very enjoyable to read. And we actually, Gan and I actually talked to Z for a long time and exchanged all kind of different ideas regarding data streaming, engineering, even startup companies. So Z and I joined Flink Forward last week. Like, I mean, actually, the same time. Today is Wednesday, and last Wednesday we were in Seattle for Flink Forward. So, for those who are not really lucky enough to join Flink Forward, do you have anything to share about that experience? Anything like you really learn a lot, or like met new folks, or get some new chance in this domain?
Sure. Yeah. Happy to share a little bit of my thoughts. And also for a little bit context, I've been involved working with Flink ever since like 2015. When Flink was super early on. In the beginning, we actually, at that point in time, I was working for Netflix. I was actually the third engineer on the team to build this entire real-time data infrastructure, right? So the first couple technology we picked was, Kafka, obviously, for the streaming transport. And the first engine we use is Apache Samza, right? So,
Right.
not after a long time, we realized, Apache Flink, even though it was like super early on at that stage as well, at that point in time, didn't have major adoptions like today yet, right? So we were at Netflix, one of the first company actually kind of switched using Flink. At that point in time, was really well known for stateful processing's reliabilities, and we got introduced, to Stefan Ellen. So we really kind of collaborate super closely together, kind of rolling the Flink ecosystem in Netflix. So that was super fantastic for me, and ever since I was involved, participating in Flink Forward, some meetups. So, really love the Flink community. I feel like, the community feels very different from, some other community, right? So there's less hype. People are really kind of focusing on technologies and, kind of building the right things. There's, I guess, these days there's more people using Flink than contributing back. So I will encourage everyone, if you using Flink, start contributing back, something as well.
Yeah.
But
So a quick note that on that is I hear you. That is, I feel like a different open source project, even all the project on the Apache Foundation ASF, might have some different personality, right? If you call that, it's like
yeah,
Flink is super uh, detail oriented, elegant, but in the same time they be very conservative regarding how to come up with a good design, or kind of break API changes, right? Even if you want to contribute to it, like for example, I guess you and I were in that party the day before the talk, and there's David, I think, from Confluent, mentioned
yeah.
that is what was the first step. Yeah, maybe you can start from documentation or some easy bug fix, but they really have a lot of process review, and they don't really want people to like arbitrarily add some minor changes to the Flink and claim they are one of the contributors. So yeah, I hear you that is Flink, the community is very active and also be paying a lot of attention to the details, right?
Yeah, I do think so. I think, if you're new to the film community, definitely I think documentation, kind of reading through the code sometimes can be difficult. But there's also a couple of things I feel like there's more opportunity to contribute back as well, right? So one is Flink engine, as a stream processing engine, is very good at doing its thing, right? Optimizations, and exposing Flink SQL these days, to allow unified processing, all that kind of stuff, right? But one of the challenges for using Flink is around operation. It does require a very sophisticated team, to manage and build, infrastructures on top of that, right? And also, you mentioned about maybe it's less mature, like in terms of the product as a product, easy to use product, for the end users. So there's a lot of opportunity around, how do you kind of think about leveraging the engine underneath the hood, but also kind of creating this open composable ecosystem to make stream processing more feel like a product in the future. Yeah.
Okay. And sorry to put you on the hot seat. So what's like top 3 takeaways if you want to share with people who didn't attend this Flink Forward?
Sure. Let me think about it. I think there are a few things. One is, I think one thing I get the most takeaway is seems like there's a huge push around stream to batch unification within the Flink ecosystem, right? So I think it materializes on 2 different fronts. One is a combined execution mode, right? So when the engine underneath the hood will be able to make smart decisions around whether to use batch processing execution mode versus stream processing execution mode. I think that is a great push from the community itself. I also, recently attended the Confluent conference as well, right? So they also mentioned similar approaches towards that. So I feel like, that's a great thing to push towards that, right? And the second thing is, they announced this thing called a streaming warehouse, which, right, essentially kind of brings the stream processing and data warehouse together as a unified solution. I think underneath the hood, Alibaba invented kind of push for this open source project called Apache Paimon, which is relatively new. I think it's built on top of a Flink table, which was, it started as Flink table, but evolved into Apache project. So I think those are the 2 main points, I guess, kind of materializes as a string and batch unification story. I thought there was some excitement around that. The second takeaway would be, I feel the community is also pushing towards a cloud native implementation, because Flink, similar to Kafka, right? I think it came out almost like 10 plus years ago, right? So at that point in time, the cloud ecosystem wasn't like super mature. So a lot of the designs was centered around distributed systems, state management, within a single compute node, right? But these days, given that all the cloud ecosystems are evolving, there's opportunity for leveraging kind of object stores, things like that. One other example would be Warp the Stream, right? So kind of coming up, becoming a cloud native implementation with Kafka native protocol, which can be interesting, in terms of saving costs, right? So I feel like Flink is also pushing towards that direction as well. One of the new features I think they're going to release in 2.0 is called disaggregate state, if I remember right? Essentially kind of separating the compute and checkpoint state management. So that would potentially kind of bring Flink more friendly as an operational engine on top of a cloud ecosystem. I only wish to have that about 10 years ago. In 2015, that would actually save a lot of trouble. We build a platform on top of that. In Netflix. So that was the second thing. There was quite a bit of a kind of exciting new features being mentioned in the 2.0 release, which is also exciting. I think
but it's more like a preview, right? The final release will be come out next year, I guess, at their maybe 10th anniversary of the Apache Flink project. Yep.
Yeah, that's actually pretty exciting. I'm looking forward to that. I guess the 10-year anniversary conference in Berlin. So we'll see. What they do.
Yeah. I guess it's not really a rumor that it will be much bigger, right? And there's a lot of heavy user in Europe and. I'm not sure the headquarters is in US or in Germany, but certainly there's a lot of people coming there. And also like 10, 1, 0, like in a binary way, it's also 2, right? So it's a good timing to release or celebrate the Flink 2.0 at the 10th anniversary. So if I remember correctly, that is, you mentioned unification, streaming house, and cloud. Yes,
Right.
again, there's a lot of topic. Even it's just a 1 day session, but there's a five slots, right? 5 different track in the same time. It's very easy to lose or miss some event. But I guess the slides and recording are available. If not, but will
Well,
be very
actually,
soon. Yeah.
yeah, one more thing I do want to mention, there's many companies participating in this conference as well, right? Apple, LinkedIn, I think DoorDash was also involved, in some of the, I guess, one point I'm trying to make here is, it generally, I think streaming architecture is, I don't know what's the right word here, consolidating or, like emerging as streaming patterns. Many companies actually kind of re-implementing similar patterns across different company, right? And it is definitely getting more mature. For example, I think DoorDash was mentioning about this kind of using stream processing to replace some of the log processing from New Relic, right? And being able to build a metric ecosystem, on top of Flink. So that was interesting. Yeah, it just kind of escaped me a little bit, but there was quite a bit of interesting talking from the, all different companies as well.
Cool.
So if you get opportunity, do check out the video recording. Yeah.
or talk to your boss to get the travel budget to travel to Berlin for the next year's event. That'd be awesome. And the reason I bring Gang, our CTO, to this interview / podcast is you two really work on streaming ML or ML AI for a long time.
Yeah, thanks, Joe. Welcome, Z. So actually, I have a question about the Flink because I believe your mission or your company's mission is bring real-time ML to the users and enterprise, right? So
Yes.
and I think Flink is one of the key component that help you to fulfill your job, right? Your mission. But my question is like, how can because to me, that actually Flink can do two things in the real time world. Right? One is that Flink is a real time data processing can be used as a data processing pipeline to help you build features, real time features for your model, right? But at the same time, in the past, I know that a lot of people actually were developing like machine learning, the real time machine learning models. Like you can train online model using Flink, right? So that means you spare to bad training. Instead, you develop some new algorithm based on the incremental models, right? Model training. So you use Flink. Flink actually have that capabilities, but when I read the blogs or architecture, I found most of the real-time ML architecture just use Flink as the data processing pipeline instead of using Flink as the online models. So how's your take on that? So maybe you have some opinion or your observation about what's the best role for Flink, for the real-time machine learning architecture. Yeah.
Yeah, that's a very interesting observation. To be completely honest, right? So 2 years ago, when we started off building this company, we started the vision with continuous training, right? So essentially, exactly what you are describing there, having a way to continuously train the model to adapt to changing situation, right? For example, on Black Friday, you're expecting the traffic pattern coming might be very different, right? So if your model can adapt to, changing situations, then make you, if you're running a website, retail website, that probably kind of increases your revenue for that one single day, right? So the learnings we had there was we initially started thinking about kind of doing this continual evaluation of the model itself, because when you have the models being able to evaluate in real time, right, understanding the performance characteristics, the accuracies of the models themselves in real time, it helps you to build systems like A/B testing on the model itself, so you can make real-time decisions around which model you want to kind of be plugged into production, right? So that's the first step in terms of kind of doing continuous training. But at that point in time, you have insights into how the model is performing. Doesn't necessarily mean you have to do continuous online real-time training at that point just yet, because you can still do batch training but with shorter intervals, right? So even if you can on demand change this model, after 1 hour training, that's still gonna give you the benefit. So that's exactly what we tried in the beginning, right? But ultimately, the market tells us, might be a good idea, but the market is not ready for it yet, right? So, personally, I do think it's still a good idea, but it might take some time for the rest of the dependencies to be resolved, for the machine learning market to move towards that, right? And also, given the large language model, that's happening right now, that's actually pulling some attention away from the smaller models, right? Even though I do believe in the longer term, smaller models and large language model is gonna have to work together. But the market, I guess, we have to wait for a couple of the dependencies. One is, today, most of the companies are still stuck in this situation where, they are in a data rich but outcome poor sort of situation, right? So means, they have all the data, but they're not able, to kind of process all those data in real time and turn those into insights to feed into the model first. So realistically, feature engineering or data analytics, right? So those are all the dependencies where you have to get those things done before even talking about continuous training, right? So I feel like that's very important. And then the other thing is actually we have to kind of really wait for the real-time needs to emerge more and more, because today, if we look at all the real-time needs, it most particularly kind of be confined within the scope of tech companies, right? So I think most notably Google does their ads processing in real time, right? So Meta has a lot of interesting kind of processing technologies in the real time space as well, right? But and also more recently, LinkedIn, DoorDash, those companies are actually also starting to realize the value of kind of changing from batch features into real-time features that actually kind of help them to lift their business metric quite a bit as well, right? But oftentimes we're still talking about this confined within the tech industry. It's not so much involved in traditional industry like logistic, healthcare, and things like that, right? So I think that's another dependency. People need to realize the value and see those in their businesses. But obviously, there's other dependencies as data fragmentations, all that kind of stuff. So I do believe, in order for real-time data to push forward, to realize a lot of value in the entire industry, I think there's a lot of dependency work on the data platform itself, right? So data governance, composable architecture, to help companies to be able to easily bring things together. All of those things matter. So if we're talking about the longer term vision on continuous training, real time machine learning, I think we need to stay grounded on solving some of these fundamental issues first.
Okay.
Yeah. So if I understand correctly, that is you are saying continuous machine learning is definitely a better feature, but compared to what is right now, which is batch, we might end up with something in the middle like macro batch or not so real time, but improving the kind of low data quality, less data lag. But we will, with the effort from all the community, big companies, small companies, we will move into the continuous machine learning or training eventually, but it may take a lot of effort and it's really need a lot of kind of work from all the components. And you mentioned that data pipeline, data stack are not, we are getting there, but still there's a lot of training or mindset shift or tool upgrade, right?
Yeah. So I think, one point, maybe kind of adding a little bit more details on that, right? So I do believe batch and streaming needs to work together in order for us to kind of reach this longer term vision of continuous training, real-time machine learning, right? One concrete example here would be, for training, today it still largely kind of depends on batch data, right? So you need time travel joins, to be able to, to work on a large set of data. So batch processing is the right way to do it, right? But for example, if we need to do like online inference, so getting the most fresh features computed on, data processing side, that would be very important, right? And how does actually stream processing to work with some of the storage layers, like key value stores for serving, some of the features, while at the same time, how do you kind of keep data consistent between the online served features and offline training data set? So, well, in short, not delving into too much details, I do believe the current state of the industry needs to kind of combine the different capabilities from different engines and have them to work together. There's a lot of work involved in terms of building the proper abstractions, having the right language front ends, having being able to to manage data governance, data lineages. I think all of those are fundamental kind of data platform capabilities, right? So how do we kind of bring those together in order to push, the real-time vision forward?
Mm-hmm. Right. Yeah. My take for this is actually, I think we can still build real-time machine learning, right? It doesn't matter it's online training or bad training, right? But the most important, like maybe most beneficial way is get the fresh feature, right? Leverage streaming processing like Flink or whatever streaming technology, build fresh feature. And with fresh feature, you can actually, the inference is more important. You get low latency fresh feature to get the latest prediction result, right? But the online training maybe is the future. But the benefit it is really good, right? But to achieve that, maybe at this point, right? Because Zhenzhong, you have mentioned that infrastructure or dependencies is not ready, people are not ready. If we really do that, it's still doable, but it's really cost too much, right?
So shall we, if the end goal is continuous training, but it's take a lot of effort, but do you think that like real-time feature store or like streaming feature store is mature enough today? What's your opinion? Yeah.
I think this is an evolving space. Certainly technology is still evolving, but we have good enough technologies to be able to do real-time feature inference, model inference with fresh features. So, I think there was some discussion during the Flink Forward conference. I bumped into another person. They even thinking about using like a streaming warehouse, streaming warehouse, whatever they call it, right? So so Apache Paimon is something that directly integrated into Flink that allows you to to ship all the states onto Apache Paimon. So imagine you have a way to kind of materialize the states from Flink directly into a key value store, like serving layer, right? Mm-hmm. So that allows people to access fresh feature without actually using a separate data store for that, right? That's one approach. Obviously, a lot of the approach, other companies will actually leverage Redis, some other stores. I'm not sure Timeplus may also be kind of fit into this kind of scenario, right? So maybe kind of generating features. Actually, out of curiosity, does Timeplus actually can be used as a feature store? Has anyone used that?
It is true that is Timeplus and other we call so-called stream database can be really good use case for feature store, right? So imagine you get all the data coming from Kafka or coming from all kinds of batch or macro batch streaming data source, and you can just create your continuous aggregations. You can do some downsampling. You can filter out some dirty data easily using SQL, leave them in the database for the serving, right? So I guess this is one step towards the previous approach, which is you have a streaming processor like Flink, then you process it, then you send to the other OLAP, or they send to S3 or data lake. Then you're using the other tool to load the data from those S3 from OLAP. That will create extra data latency, and also data is saved in multiple places, and there's no really good communication between the stream processor such as Flink and the OLAP. But now this new trend, it is a streaming database that is, you have a database, but that database providing the streaming processing capability, but data is living there. You can have the full, say, JDBC, ODBC, or REST API serving layer. So you don't really talk to the other system. It's still there, and you always get the latest version, no matter by having ad hoc query or using stuff like materialized view. You can always get the latest snapshot or the continuous kind of change of your feature. So yeah, we already see some use cases, people using Timeplus or Proton such streaming database as a feature store. Yeah, right. Again, yeah, we're looking forward to have more users to give us feedback on that. Yeah.
So for the real time feature store, there's some challenges. The first one is a fresh feature and low latency, right? So first, Timeplus, we have a very high performance engine, so it really provides very low latency data processing. So the second one is the correctness or the consistency between serving and training, right? So actually, for example, you are looking for the point in time correctness, right? in Timeplus, actually we have all the we are like time-based data, like stream. All the data has timestamp. And if you're using streaming SQL, we can easily help you to build like a as of join, so you can get the data aligned by the as of join by time, so you get the point in time correctness for all the features. And last one is actually for the complexity, but this is a like platform we help you to manage the complexity. If you leverage Timeplus, right, you don't have to manage like Flink, Zookeeper, Kafka, or whatever. So we help you to manage everything together, and we because we have both historical store and real-time store, right? We help you to unify the batch processing and stream processing. So that's why I actually leveraging stream database is a good solution. If you want to build your own stream feature store, actually this streaming database is a good choice.
I think streaming database is very interesting. It's a new and upcoming concept, right? Which covers some of the gap. Where maybe the biggest difference between Flink and streaming database is now you're adding this kind of storage capabilities. Allows you to do different things with the storage. Play around a little bit. Maybe you can do real-time serving or batch processing. All of that done in a single system, right? So for data scientists, that's actually a huge plus because they would love to work with like a simple interface, working with system that just works instead of kind of having to work across many different systems and bring them together, right? So this layer of abstraction is going to be more and more important, for higher level users like data scientists or analysts, right?
Yeah, actually, I'm planning writing some a blog talking about that. So yeah, something I would like to ask Jinru about your opinion, like because for example, I'm a data scientist. I want to create this real-time features, right?
Yes.
I think most of the data scientists or data engineers, they're so familiar with the tools like Python tools, right? When I build clean my data, I use Python, Pandas, NumPy, or other tools, and training my models. Then I validate the model. It looks good, right? And when you serving your models, you have a data pipeline like Kafka, real time data. You have Flink to transform the data, and in Flink you probably use SQL or Scala, right? I don't know which one is more popular, maybe. But fundamentally, it's inconsistent, right? If you use Python pandas, even you can write SQL in pandas, but most likely you won't do that, right? And if you're using the streaming pipeline to develop a feature, fundamentally you have two. It's a traditional like batching or streaming inconsistent, like in a Lambda architecture, you have two code lines, right? How do you make them consistent, right? And also you cannot scale your Python features, right? You have the Flink is scalable, right? You have really large number of data, so you can a large data pattern. So because at Timeplus, if you leverage a database or streaming database to build the feature stuff, most likely you are using a SQL, right? You write all your features in SQL, right? So how's your opinion about that, right? Which one is the a good way to provide the user the like I know you mentioned about the unified interface, right? We don't have to unify the engine, but to unify the interface. But how do you unify such kind of feature interface to your users? Right?
Yeah, but I start with analogy here, right? Many years ago, right? So when electricity was just invented, right, it was a lot of hassle, to be able to leverage electricity because you need to work with, the factories. Back in the days, they burn coals, right? Today, they have nuclear power, right? So there's also green powers, all that kind of stuff. There's just different ways of kind of producing that power, right? The abstraction layer for between the consumers and the factories are essentially we have it's ubiquitous, it's everywhere. If you look around you, you find that wall plug right on every single wall, right? So to consumers, you can just easily plug your electronic devices into the wall. I don't care about how the underlying power is being generated, whether it's green electric burning coal or having kind of nuclear power, right? So the benefits of that is it's really kind of accelerating all the innovations on both sides. right? So in the consumer side, there's many company focuses on building better, electronics, satisfy their own customer bases and things like that, just because they having access to that unified interface, right? They don't have to worry about building a different device for different engines and things like that, right? On the other side, for all the power factories, they can also focus on kind of really drawing out the efficiencies, right? It increases the competitions in the industry, but ultimately at the end of the day, kind of really promotes on bringing the best to the market. So having that standardized abstraction is going to be important. And this, the reason why I'm kind of bringing up this analogy is I think it's also important in the machine learning, especially real-time machine learning space as well, in terms of kind of bridging the gap between batch features and real-time features. Do you need to have separate interfaces? Probably not. If you can have a single shared interface across different type of data processing, but providing the knobs to your users, right? Having them to specify, I don't care about this feature can be available within a day and it's not going to impact my model that much. But this feature needs to be in real time because, for example, I need to understand the user session intent, and that will be an important signal I need to get in real time to influence, this model outcome, right? So, but how would that materialize? I think, that's a very interesting question. I think, Kafka is one of those engines actually does provide really great, kind of streaming capabilities, streaming storage capabilities, right? I would love to see a world, where, Kafka can work with, data warehouse engines like Iceberg as an example, Delta, things like that, right? So as you kind of streaming data through Kafka, a copy of that data may be backed, in Iceberg, for example. Iceberg is gonna be way cheaper, right? So probably 100 times cheaper than using Kafka because.
But that's the direction for those people working on the tier storage, right? So no matter
exactly.
even WarpStream or Rapanda or Confluent, also Evelyn, they all try to provide, or Posa included, to provide tier storage, and eventually the code data might be somewhere in the object storage like S3, but you might still consume that using the Posa or Kafka API.
Exactly. There needs to be some work, around, kind of doing those integrations. There's like standardization around like in-memory format, on disk format, things like that. Let's not delve too much into that, right? So, but my entire point was around, what does this abstraction look like? If we're talking about machine learning, right? On one side, it's going to be the data scientists use some sort of abstraction to access, all the different data storage processing, those engines underneath the hood, right? So this abstraction layer, I think Gang alluded to earlier, right? So a lot of people might have to kind of choose between SQL and Python. I think, in the current state of the industry, I've seen both. I've seen data scientists actually use both SQL and Python, depends on their workloads, right? So SQL might be sufficient for some of the simpler workloads if they don't need to kind of leveraging existing libraries, if they don't have any algorithms implemented in Python libraries, or wanting to use some sort of existing toolings like scikit-learn, or PyTorch, things like that. That might be okay, right? On the other side, for more sophisticated, kind of processings, people, data scientists do use a lot of kind of Python ecosystem libraries, and it's becoming more and more important to, to have this Python interface as well. In my ideal world, the Python interface and SQL interface should be interchangeable with each other. You can implement once, and doesn't matter, how you implement it. You can either choose to translate that into a SQL statement, or use different engines underneath the hood. That would be the ideal world, to have this kind of standardized abstraction layer for data scientists to access all the power underneath the hood, right? And also longer term, I do also believe, eventually everything kind of consolidates back into SQL, because that has been, the case for the past 50 years, right? People invent new things and eventually kind of consolidate back to SQL. I do believe in that too, but given the current state of the work for this decade, I think, we're going to see Python and SQL have to work together.
Yeah, it's a broader statement, but I guess probably will be true. You might be right. And also, like, people keep inventing new stuff, like the module, right? They claim to be something similar to Python, but way faster, even can kill certain kind of Rust or C++ workload. People keep inventing new languages, but you're right. That is, there are so many nice libraries in the Python world already, and some people even try to keep the library in Python, but replacing the implementation to like Rust or C++ to improve the performance or efficiency. it's also a good
Yeah,
change.
but there are things, that don't change, right? Despite, if you change your language or things, so the relational expression, which is has been a proven way to, kind of describe data, declare how data needs to be processed. For example, in Flink, Flink SQL, right? Apache call site was being used, for doing some of those things. So if there's a standardized layer for kind of capturing some of those relational expression, you can easily kind of switch between SQL style, Python style, whatever language you're in. Yeah. But there's also other challenges I feel, around this standardized layer might require some thinking around, UDF and connectors. Because one of the other observations I think I'm observing right now is every single engine is implementing their own connector ecosystem. And, imagine how many engines out there today, right? So it's gonna get out of control pretty soon, pretty fast. so I think we as an industry have to start thinking about like what's the right way to implement connectors. So again, it should be implemented once and work across different engines. How can we get to that? I think there's some technologies around, like Apache Arrows, lays down some of the foundations for those ideas. But I think it is something we have to kind of think together as an industry.
Yeah, there are so many Connect framework, right? Flink Connect, Kafka Connect, Airbyte, Meltano, There's so many different things.
Even at Timeplus, we built several different connectors, right? Kafka one,
yeah.
And we leverage like Benzos. Benzos has this connector framework, and we support Airbyte and some other ones, right? Like every different platform has their own connector.
But it's also depends on what's the underlying tech stack. If you're Java, it might be difficult to leverage some of the Python connector, right? Or maybe Python will be slower, or how you handle like clustering, failover. There's a lot of details. I guess it is. Yeah, I hope it will be a standard for connector, at least for each language. We don't really have to. For example, all the companies such as Confluent spend so much effort to produce and review and improve the UI and experience for Kafka Connect. There are so many ways to say send data to, say, Snowflake, for example. But if today you want to use other tool not using Kafka, want to send data to Snowflake, you might have to start some low-level SDKs. Or people in the Flink community have to. I noticed there are maybe at least 2 or 3 different Flink connector writing data to Snowflake using the latest API, which is not easy actually, right? Because there's a lot of details to handle. So having a single connector, that'd be great. Yeah.
Yeah, my thinking there is, there are going to be some foundations we can leverage, right? So, for example, are there any, for example, Apache Arrow, right? So kind of lays down the foundation of in-memory columnar format, which is essentially your WAL format. If you, on top of that, enable RDMA across different engine runtimes, even if you're in C++ runtime, you can still directly access that memory, getting the data you need. I think that would be the foundation for some of the connector things, right? But also, I feel like another challenging part is UDF, right? So I think there has been some attempts before on solving, kind of unified UDF, and Apache Beam has been one of those attempts. But there's also a lot of challenges, in that particular attempt as well. I feel, right, in order to push real-time machine learning, the entire data ecosystem, some of these things, fundamental things, needs to be addressed first. And that requires like entire industry's efforts and thinking towards it.
Yeah, even UDF, you define your user-defined function in, say, JavaScript or Python. In different systems like Snowflake, in Oracle, in Timeplus, we might use a different syntax, or even the programming model is different, right? Then, this is also the other challenge. And people are talking about whether we can leverage stuff like WebAssembly, but I'm not sure how flexible it is to support like cluster or like sharding, all those details. So you're right. The connector and UDF is a good way to extend the current SQL engine to reach out to other systems or do more things. But you're also introducing other problems, right? Which is you might have to build a solution for each database, and there's no really universal industrial standard for that. Even Timeplus, we're actually lucky enough in that kind of SQL working group to try to enhance the streaming SQL. But me and Ken in that discussion, and we really respect all the experts in that group. But again, it's very difficult. It's big effort, and it takes a lot of effort and time to come to a good conclusion. And each vendor update their implementation to move to that new direction.
Yeah, Jejo, I have another streaming processor related question related to ML, right? So for Flink, actually, one of the features is actually the complex event processing, that's CEP, right? So that means we can leverage streaming processing to identify patterns, right? For example, event A followed by event B, and then followed by event C.
Yes.
And this is a specific user pattern. And then if I identify this pattern in the streaming, maybe the user login or some user actions, then I need to take actions, right, to identify like an anomaly or something, right? So this is stream processing is like a rule based, right? We identify this pattern and then we take some actions. It's a specific streaming processing rules. And some of our customers really need that for the streaming processing. But at the same time, maybe if you leverage machine learning, right, you probably can do some pattern recognition as well. So, but it's not rule based. It's more like based on the probability, right? So it's based on the deep learning or some others, right? So, what's your take for the in a real time ML domain? So, which is how do you recommend your customer to if solving such kind of problems? Is CEP better, or we use pattern recognition of deep learning or some other machine learning model? So what's your take on this?
Yeah, interesting. I think like many senior engineers, I will answer similarly. It depends. So
it's always a good answer.
Yeah, but I can share some of my observations in the industry use cases. I do see, given that there's more and more data being collected, right? So the user behaviors are getting more and more diverse. So especially in the security space, I don't know your customer base, but I think some of our observations, like in the security space, there's just many historically they are able to define this rule engine to be able to detect certain frauds and things like that that would be sufficient. But given another statistic I've recently kind of been hearing, right, 90% of the internet traffic on websites, the request response are being generated by bots today, right? so that's essentially kind of creating a new dimension of amount of signals you will be receiving to determine like how things are, whether things are frauds, whether this is actually, generated by human or by bots, right? So it is inevitable for a lot of this type of use cases to move from rule-based systems, into machine learning systems. But also machine learning real-time machine learning system is not panacea, right? It doesn't give you 100% accuracies. If they do, I will follow their advice, on buying stocks and things like that, right? So it still needs to be that continuous process on, making improvements. So machine learning ops is something definitely fundamental to this entire thing to help pushing some of those processes forward, right? I don't think, the industry is fully there yet in terms of having, a consolidated or patterns of kind of patterns on how to kind of manage some of these machine learning workflows yet, right? So the industry needs to kind of continue pushing on that. At the same time, there are many use cases today are still can be fully satisfied by rule-based systems. So it's not it's here to stay. It's not going to die anytime soon. But we do have to kind of make sure we have a path forward on bringing enough toolings to help with machine learning to make some of these real-time decisions.
Yeah, great. Yeah, actually, that's also what happens when I was the machine learning work for the machine learning team at Splunk, right? So we developed some models that can, category or classify the log event, right? Classifications, and it was good, but still people in the Splunk world, we still think that the rule is better because, like you mentioned, rule doesn't make mistakes. There's it 100% precisely give you a result. But with the best machine learning model, you can achieve like a 98%. But still, there's 2% errors which people don't like. We don't like uncertainty, right? But I think this is changing, right? Because more and more people are using large language model, right? And one of the I think the great feature of the large language model, in most of the case, you don't set temperature to 0, right? You love you enjoy the uncertainty because most likely LLM is using in the content creation. You don't want to create content every time you don't want to create some same content, right? But so things are changing. But I think there's a like you mentioned, we need to there's progress, right? People in a lot of areas maybe it's okay to have some errors, right?
Yeah.
But yeah, in some areas specifically, rule has its benefit because we don't allow errors, right?
Yeah, for the security, yeah, it's definitely different than the creator market, right? People don't want surprise. They don't need a personality. They want something accurate. Either they can act on right now or they can fix bugs. But also, like having too many alerts equals like having no alerts, right? People will not pay attention to millions of alerts one day. So that's really interesting space. How to balance, how to know your unknown, but don't have too many false alarms.
Yeah. My other take on this one is it needs to be incremental, right? So, before you can rely on machine learning to make fully automated decisions, you need to be able to, to make semi-automated decisions and still having humans in the loop, right? So maybe analytics is part of that solution going towards, because you need to have like real-time analytics, right? Allow human to go in there, understand what's the current situation. If I use this one particular rule or model, does it actually generating better results in real time, so I can make real-time decisions on shifting things forward, right? So before that, similar to kind of software engineering, right? So you need to kind of have a shadow pipeline to run things first, right, before you fully trust the pipeline, to move that into production. So maybe that's why I think a lot of the analytical solutions today still needs to be involve human in the loop to begin with, until build that eventual trust, for mission critical use cases, then we can have a path forward. So yeah.
Maybe my last question, the Flink had this unified Instagram streaming together, right? Assuming the feature is there already. So is it good enough for you to build like a real-time, ML architecture? You can remove the historical, like ClickHouse. You don't need ClickHouse. I just use the Paimon of the Flink. Do you really want that, or does that solve your problem? Right?
So I haven't tried Paimon yet. So I think there's some interesting concepts being mentioned, right? But also Paimon is not the only solutions out there, to do this. I think they have their niche in terms of using, some very different kind of data structures underneath the hood, log structure merge tree as a storage layer, right? That has its advantages in particular situations, but may not be advantages, in other situations, right? So I think in my mind, it's more about identifying, I think from an engineering point of view, right? So, we have to kind of look at different systems and, how the data is being stored, how the retrieval patterns are, and what is actually my use cases. And then, ideally having that, decision layer, like for this type of a workload, it might be better to use this particular engine, for example, stream processing. For that type of workload, if the latencies or freshness is not like super important, but I would rather, to optimize for like certain type of joins, like bucket joins and things like that. Maybe, I use a batch engine, right, over a batch storage. So again, I think it's about kind of bringing those things together to serve the customer's needs. You know, you know, uh, Maybe that's also the reason when we actually working on generic machine learning platform, we need to have work with many different kind of engines underneath the hood. But if you kind of go into specific machine learning scenarios, you might be okay, to work with one specific engines underneath the hood and then still satisfy most of our customers. And so far, we are working kind of more towards the generic use cases. And I think it would be great, for us to kind of start, when mentioning about the abstraction, right? So I think one of the biased idea maybe I have here is I would love to be able to to work with different engines underneath the hood to see like what particular use cases we can satisfy together.
Okay, so a follow-up question that is, you mentioned you guys work on the generic problems or framework. Do you use like Flink Spark in the same time, or something like Apache Beam to providing the abstraction layer?
Yeah, so we're not using Apache Beam. We're trying to build this abstraction layer ourselves, right? So it's essentially a relational expression layer that we can, serialize that into a query plan and then, translate that into like different engines, for example, Flink SQL, right? So that's how we essentially kind of enable our data scientists to use a Python interface, but without actually having to, ask their data engineers to translate the workloads into a Flink engine. We can do that abstraction, translation layer for them. So with that technology, we can actually translate it into different dialects of SQL. We can, use different engines, underneath the hood. We also in the process of kind of combining the capability of processing and storage. Obviously, that's the reason why I'm pushing for the industry adoption for like unified UDF and unified connectors. I think that's important. There's a value for industry, but that's also extremely important for us as well.
Okay, cool. And also, as a host for this podcast, let me shamelessly plug in the Timeplus supporting in. I mean, it'll be nice if we can work together to leverage your business logic framework to like generate SQL work nicely on Timeplus or Portland, right? So it can be one of the streaming database for you to handle both streaming and the batch workload, and also providing the serving layer or ML or UDF stuff. And also our engine is already open source on the Apache V2 license. It's very easy to use, and you can even customize it, host or run by yourself. You can get the link from our company website. I will also share the website for this website, company Claypot in the YouTube description. This is, I guess, just the beginning, right? There's a lot of stuff topic we can discuss, and I'm sure we can meet each other in other conferences, and people keep inventing new stuff, creating new problems in the same time. But that's the fun of in this data space, I guess.
Yeah. Yes.
Yeah.
All right.
Thank you, everyone.
Thank you, and see you in the next streaming Caffeine or in the next technical conference.
Cheers.
Thank you. Bye.